Welcome back. This is day 11 and the final day of our Solving Quadratics unit. Today we'll be continuing to solve word problems involving quadratic equations. Just a reminder, a copy of the handout is also provided in the description so you can follow along. Enjoy. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Alright, let's do this. Do it now. This is directly from a problem from yesterday. Again, our project later on will be based on this one. So a soccer ball is kicked straight up in the air. The ball hit the ground after 5 seconds. If the ball was kicked from approximate height of 3 feet, what was the initial velocity of the ball? So now that you've read this problem, we're just kicking the ball in the air, and we want to figure out, the question we're trying to figure out is, what is the initial velocity? That's what we're looking for. We're looking for what is the initial velocity. So we want to know, what is this? What do we know from this problem? We do know that the person kicked the ball from a height of 3 feet. So that means we know the initial height is going to be 3 feet. All right, so let's see if we can figure out what we're trying to do here. Also, we know that we know the ball is on the ground, so we should know the ball is on the ground, so the ball should be at a height of 0 when t equals 5. Does that make sense? Because it says the ball hit the ground after 5 seconds. That means the height was 0 when time is 5. All right, so now we should be able to solve this problem, no problem. So we'll use our formula that we have here. And since it's written, I'm not going to rewrite it. But let's go ahead and solve this. So we have 0 is equal to negative 16, and t is going to be 5 in this problem. So 5 squared plus my velocity is what I'm looking for, so I won't know that. Time is 5, and your initial height is 3. Perfect. And this looks like it's an easy, we only have one variable. Let's find the initial velocity. So let's work this out. So this should be negative 16 times 25, because we're doing 5 times 5. Plus, I'm going to rewrite this, 5 times the velocity, initial velocity, plus 3. And let's just continue to work on here. So this is negative 400 plus 5 times the velocity, initial velocity, times 3. So 0 equals negative 397 plus the same thing. All right, we're almost done here, so let's just move this over. So we got 397 is equal to 5 times the velocity, and then divide both sides by 5. So my velocity will be equal to 397 divided by 5. And that is approximately, with my calculator, that is approximately 79.4 feet per second. Okay? Now, again, most of us don't, when we speak of speed or your velocity, we're usually talking miles per hour, like when you're driving a car or you're throwing a ball or something like that. So let's just go over to Google and see what that says. What is that in terms of your speed? All right, so looking at Google right here, I've already typed in the 79.4 feet per second, so I already have that in there. And Google says that in miles per hour, that's 54.1360. Okay, so about 54 miles per hour. So this in turn means that the speed is going to be 54 miles per hour. Now, again, I always wonder what the pros, how fast they kick. So if you can kick a ball in the air and it stays in the air for 5 seconds, probably from a height of about 3 feet, then you probably kick the ball around 54 miles per hour. Pretty interesting. All right, let's try this problem. Again, this is a large paragraph, and I had a little typo in there, so I'm just deleting that. But it says NASA creates a weightless environment by flying a plane in a series of parabolic paths. The height h in feet of the plane after t seconds is in parabolic flight path can be modeled by this equation. the passengers experience a weightless environment when the height of the plane is greater or equal to 30,800 feet. For approximately how many seconds do the passengers experience weightlessness on such a flight? So the first read, I know what's going on here. So we're talking about, NASA wants people to know what it feels like it is to be weightless. So they're gonna fly a plane, and then the path is gonna be that little U-shaped graph right there. And if we get above that red line, if we get above that 30,800 feet, then we are weightless. So then we start floating around. Okay, so pretty cool. All right, let's read it again. Second read now. The second time we read this, we should be looking for what is the question. Okay, so this is our second read. NASA creates a weightless environment by flying a plane in a series of parabolic paths. The height h in feet of a plane after t seconds can be modeled by this equation. The passengers experience a weightless environment when the height of the plane is greater or equal to 30,800 feet. For approximately how many seconds do the passengers experience weightlessness on such a flight? So the question is how long. That's a time question. So it looks like we're going to be finding some time. So how long will they experience weightlessness? Okay, so that's what we're looking for. We want to figure out in this problem how much time do they feel like they're floating up in the air. Okay, so let's read this one more time. And remember, our third read, the third read is to figure out what is important information. What is the important information in this problem that I need to know? Okay. NASA creates a weightless environment by flying a plane in a series of parabolic paths. Don't really need to know that. That's not, yes, I know it's a parabola, but that's about it. The height is in feet. Okay, so that's important. And after t seconds. Okay, so we know that h stands for feet, and we can see that on the graph too. So we can see that t seconds and h is in feet. So that makes it nice. And it's modeled by this equation right here. So here's the equation that models the plane. So as this plane's going around, it's using that equation to map its height versus time. All right, so I'm just gonna make this blue also. Okay, perfect. The passengers experience a weightless environment when the height of the plane is greater or equal to 30. Okay, so this is the important piece. This is from this point on, once we get above this height here, and we have it on the red line there, it's already drawn. So this point right here, once you get above that height, then you're weightless. For approximately how many seconds do the passengers experience weightlessness? Okay, so there's our problem. So what do we know in this problem? Well, what are we looking for? Since I want to know time, I want to know what this point and this point. I need to know the time of these points. So at what time? So if you draw a little line down here, and this is t, and you draw this, and this is t also, let's call it t1 and t2, then I want to know what those times are. Because if I know those times, then I can just subtract them, and I can find out, oh, the plane was in the air this long. So I need to find out what is the time at this height. So what we're really looking for in this problem, we're looking for when is your height equal to 30,800 feet. So tell me what the time is when that happens. If we can figure that out, then we can solve this problem. So let's go ahead. Let's use this equation. Let's see if we can solve it. Now I know it looks a little crazy, but again, you've been doing this for a while, so this shouldn't be too bad. Plus 700 t plus 21,000. Okay, so there's our equation. And what do we say? We're looking for, again, we're looking for when is the height, what time is my height this? So I'm going to use right here where height is, I'm going to plug in, I'm going to substitute in that 30,800 equals negative 11t plus 700t plus 21,000, sorry. Now, there's my equation. Now, that's a quadratic equation. We can solve that First thing I'm going to do is I'm going to set this equal to 0. So I'm going to subtract that 30,000 over. So I'm going to set this equal to 0. So this will be negative t squared plus 700t plus 21. Oh, no, not 21,000. We need to subtract that. So what happens when I subtract 30,800 from both sides? That gives me, it's a negative number. That gives me negative 9,800. Okay, so all I did was subtract 30,800 from both sides of my equation. Now, this gives me a quadratic that I can solve. I can figure out what this answer is. So again, we're going to use our quadratic formula. So we're going to go x is equal to negative b, or this one will be t because we're talking about time. We're not using x. So t is equal to negative b plus or minus the square root b squared minus 4ac all over 2a, all divided by 2a. Okay, now I'm going to substitute. Remember where a, b, and c are, so let's figure out. This one is a, this one is b, and this one is c. So let's go ahead and substitute in. So we're going to go t is equal to negative, what is b? 700. So negative 700 plus or minus square root of 700 squared. Subtract 4 times a, which is negative 11, times c, which is negative 9,800. All of that divided by 2 times a. What is a again? Negative 11. Okay. All right, so I just copied that down. Now here's the equation. Let's work this out. So this will give us t equals, so we can simplify this and then just some calculator work. So then we'll be going to some Desmos problems. So negative 700 plus or minus the square root of, that is 49, and so that's 490,000. And then we are going to subtract, because negative times negative times negative, and that comes out to 431,200. And then we're going to divide all of that by negative 22. So t will be equal to, all right, so let me simplify this a little bit. Just a little bit of calculator work. This will give us negative 700 plus or minus the square root of, what is that, 58,800. All of this divided by negative 22. Okay, so there's my answer. Now, I want to go see what that answer is. That's just calculator work. So let's take this over to Desmos, and let's find out what this answer is. Let's find out. So I've graphed the original equation. So the original equation has, here's the original equation. I graphed the original equation. That's that red graph right there. All right, I used Desmos. Remember, you have to do it twice. You have to do one with the plus and one with the minus. So again, I did one with the positive sign right there, and I did one with the minus sign, or subtraction sign. So then I get my times. Here's my answer. So t is equal to, it looks like 21 seconds, right around 21 seconds. And the other one's about time is equal to, it looks about 43 seconds. So right there. All right. So now let's verify our answer. So this equation's right here. We know that we're weightless up at 30,800 feet. So I'm just going to graph that equation. So when I graph that equation, I've already graphed it, but I'm going to show the equation now. So let me get out of this. So let's show the equation, and you see the equation right there. So there's a blue line that goes across here. So these two answers, let's see what that is. So take a look at those ordered pairs. What do we see here? Now remember that t is your time, so So that means t is your time, and this is your height. So time and your height. So what do you notice over here? Well, my time is 20 seconds, or around 21 seconds. My height will be 30,800. And then the other point is at 42 seconds, your time will be, your height will be 30,000. So that's the times when the plane will be about at 30,000 square feet. At 30,800 feet. So now, let's go write our answer. So now we just need to figure out, well, how much time right here? So how much time were we in the air? So all right, so what did we find out so far? So we found out from using our Desmos that one of our answers was the time was approximately 20.80 seconds. So that's one time when we were at 30,800 feet. The other time that we were at the same height was at 42.84 seconds. Okay, so then how long were we weightless? How long were we floating around, or the NASA pilots floating around? Well, let's subtract those numbers. So what's 42.84? Subtract the 20.8 seconds, and we get an answer of 22.04 seconds. So what does that tell us? It tells us that we were weightless. They were weightless for about 22 seconds. Very cool. Very cool. So again, as you fly through that path, as the pilots are flying through there, for about 22 seconds, that's a long time to be floating around in space. All right. All right, this problem is for you to try. I want you to try this problem. You're going to upload it to our Schoology, and this will be your quiz. So I'll read it to you, and then after that, you're on your own. So a study found that driver's reaction time, A of x, to audio stimuli, so to noise, and his or her reaction time to visual stimuli, both in milliseconds, so we're measuring in our times to be in milliseconds, can be modeled by the following equations. The driver's age is x in years. Okay, so x stands for the year, how old the driver is, and then A of x is the reaction time to audio, B of x is the reaction time to visual. So what we want you to do is to compare the audio and visual reaction times of 16-year-olds and 70-year-olds. Okay, so we're going to compare new drivers to older drivers. All right, and then a question I need you to explain when you're done with this is, do drivers react quicker to audio or visual stimuli? And explain your answer. So in the first part, you're going to compare the reaction times of the younger to the older people, and then also the last question is, do drivers react quicker to audio or visual stimuli? Explain your answer. All right, good luck.